Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to this new NPTEL online certification course on advanced aquaculture technology. My name is Professor Gauravdhar Bhomik. I am from the Agriculture and Food Engineering Department of IIT Kharagpur. In this module, I will be discussing more very basic actually about the aquaculture and different terminologies that is associated with it. But overall, in this whole 12-week of lecture series, I will mainly be focusing on the advancement in aquaculture in worldwide scenario. What are the technology that is available which can be replicated, which can be utilized, which can definitely make people benefit out of it if they utilize it in Indian scenario to be precisely. What are the employability options those are available in aquaculture? How people not only think about employability but also think about the R&D possibility. Different R&D institutes, I mean like research and development institutes are there in India, how they are working on it and what are the lacuna that is available still now in Indian context and how that can be minimized and that can be troubleshooted. That will be discussed in details in this 12-week of lecture series. Majorly my focus will be on the advancement in aquaculture technology which can be utilized, which that knowledge can be utilized by the young generation. So that is actually my main motto. Okay. To start with, why I introduce this subject. So first of all, in Indian Peninsula, if you look into it, like properly, so it's like almost 7,500 kilometer of area is exposed to the sea. Like this is the coastal area is available. If you include the exclusive economic zone, it will be almost 2 million square kilometer of area which is available considered under the Indian territory where people can utilize it, that area for aquaculture development. Okay, so that is my main focus. So for all of you, whoever is actually listening or like watching this video right now, to get yourselves accustomed with the advancement in this sector and also get yourself accustomed with the knowledge available in the R&D sector and the experts like us, so that you will get to know, you will use that technology, you can use those knowledge in your daily life, or you can even think about being an aquaculture expert or maybe in future being an entrepreneur as well. And definitely there is a huge possibility of being a research scholar or being doing a research in this particular field. There is vast possibility in Indian context as of now. So IIT Kharagpur is actually offering this aquaculture engineering specializations where people can go and admit, and then definitely they will get some very advanced knowledge about this sector, and that can be very much useful for their own benefit and also for the development of our country in general. Okay, so that's the basic, that's the brief about the course that I will be teaching in next 12 weeks. So however, to start with, we need to start understanding the basic of aquaculture, because many of you may not know about the basic of aquaculture. What is aquaculture? For you, if you think about it, if I ask you what is aquaculture, what will come into your mind? The first thing is aqua. It's like it's something related to water, right? So in water, you're culturing something or rearing something that can be considered as aquaculture. So aquaculture practice is what you are culturing something in an aqueous medium. In general, we consider only the water where we are culturing any particular aquatic organism, and then that will give us for some particular reason. Definitely anthropogenic activity is necessary. What do I mean by anthropogenic activity? Means human involvement. Okay. So, anthropogenic activity based aquatic culture systems are called aquaculture system. Okay. Just to give you a very overall idea about it. So, what will be the concept that I will be covering in this particular lecture? To start with, I will discuss about the aquaculture. Second, what is the significance of it? We will be discussing some details about the global statistics. I will discuss about the role of aquaculture in achieving the food security in world, in the whole world point of view, and what's its way forward. Okay. To start with, as I already discussed about what is aquaculture. So, I think it is not very difficult for you to understand that any controlled cultivation of aquatic organism, whether it be fish, whether it be aquatic weed, whether it be mollusks, whether it be crustaceans, whether it be crocodile, anything. So, anything and everything that you are culturing in an aqueous medium, say in a pond, in a tank, in a open sea, wherever it will be considered under aquaculture. Okay. So, it not only involves, what do I mean by the culturing? It involves everything, right from the breeding, rearing and harvesting. Each and every activities involved with this rearing or culturing a species will be considered under the aquaculture practice. Okay. In general, for the human consumption, and I wouldn't say the only human consumption, but also I would say like different other purposes as well, we normally focus on two different type of fisheries. Okay. First one is capture fisheries and second one is culture fisheries. Majorly in a broader perspective, in aquaculture we sometimes include capture fisheries as well, but actually aquaculture not always necessary to be included with the capture fisheries. Capture fisheries means you go and get a wild catch, means you have your fishing vessel, you take your vessel, you go to the open sea, go to the say like inland water bodies and you catch fish from there. That is not aquaculture in general. Okay, that is called capture fishery. You are capturing, okay, from wild collection. That is called capture fisheries. Then there comes the culture fisheries, where you will be doing the all these practices, rearing and the culturing of your species by all by your own. That will be considered as under culture fisheries. Okay, so what makes this aquaculture so important nowadays? People earlier we don't worry about it. Aquaculture now, that is not something to be it's like taught about, just like it's something which is just go and catch some fish. It's like some hobby kind of thing, but time is changing. For the last couple of decades it's becoming a very big industry all over the world, and believe me, in coming decade it will be one of the major factor differentiating between different countries' GDP. Okay. Aquaculture in Indian context as of now, it is not contributing even 1% of its GDP, whereas it has the capacity to go up to 4% of its GDP, contribute to 4% of its GDP, and India has that capacity. That's why we are introducing this kind of subjects to let you know that what you can do, what changes that you can make. So, to change the scenario, to involve with this change, involve with this blue revolutions that is happening all over the world. Okay. So, what's the significance of it? In last couple of decades, I would say like last 2 decades to be precisely, aquaculture sector has been matured like anything. Lot of experts and the specialists are working all over the world in this sector, and then try to develop some technology and high-end information center and all, where you can get all the necessary data, necessary information related to aquaculture. Okay. In aquaculture, there is a recent trend of huge growth and the growth in the value chain as well. The fish nutrition, genetics and alternate type of feed are being experimented and researched all over the world now, and which is actually helping the aquaculture to bloom in a multiple way. Other than that, the expanded culture of extractive bivalves and the seaweeds are also considered under this aquaculture, and which are one of the major source of how to say the economic return. This seaweed, I am telling you, this seaweed is is like a green gold for, if you consider about marine environment. The seaweed has tremendous amount of like the properties, the chemical that it has a lot of applications. I would say, like, you can go ahead with the pharmaceutical, you can go ahead with the food chemical, human consumption, personal care products, medical products. Like, it's like it has a lot of applications. Okay, and at the end, if you are not after utilizing everything, after the extraction is done, this extracted, this all the nutrient extracted biomass, the final biomass that you will be getting, that can be used as a livestock fodder as well. It will reduce the overall methane emission. You will be surprised to know that this kind of activities are not being practiced in most of the part of the country, world actually. Simple change in the feed of livestock can reduce the greenhouse emission like anything. The agriculture is, especially the livestock, is one of the major reason of greenhouse in the world, especially the cow farming and all. It can be reduced because their system has developed the greenhouse gases very frequent, very in a very high amount. That can be minimized just by changing the food ingredients. So the food that you are providing to your livestock, if you add it with the seaweed and some extract of the seaweeds, there is a lot of investigations, and expert has said a lot of time that it is possible to reduce the greenhouse emission, gas emission from livestock culturing just by changing the feed ingredients and all. So it has a multifaceted application. Not only that, this seaweed, wherever you will be culturing, it can clean the wastewater, it can clean the water also, because it consumes the nutrient from the surrounding ecosystem. And suppose it is in the coastal region, or suppose it is in the, say, estuary region, where the river water is come in contact with the sea, which we call river mouth sometime. If we grow the seaweeds there, they will consume this wastewater, they will consume the pollutant present in the wastewater, and by this way you can get a fresh water out of it. I would not say like it's like fresh like anything, but definitely it can reduce the pollutant level. So these are the applications, different applications that experts have been they have found in especially if you do the seaweed culture in your territory, or in, say, like in your coastal region and all. And not only that, it will give you a lot of employability opportunity as well. Okay, the local people can get a lot of lot of job and all if you start working on this kind of new opportunities and all. Okay, perfect. So other than that, another good thing about aquaculture is like its year-round availability. You do not have to worry about like in a specific time of a year you will only get it, because it depends upon your scientific knowledge and the way you design your system and way you design your value chain. So you will get year-round availability of your aquatic products and all. Okay, it becomes a reliable source of protein and micronutrient for the, I would say, human consumption. But in future there will be a time when it will be more and more dominating foods source of nutrient and protein for human consumption for sure. Now if we talk about some global statistics, okay, remember we discussed about the culture fisheries and capture fisheries. If you see this capture fisheries in the first 3 rows, the third row says the total capture including inland and marine culture. At the end, if you in the beginning it shows in the column wise 1986 to 1995 data on an average per year actually, and there is at the end you will get at the last column you will get 2018 data. If you see the total capture from starting from 1986, it was as low as 86.9, now it goes up to 96.4. The difference is not much, right? Definitely, because it's capture fisheries. We have a limitation in the wild, we have limitation in the nature. You cannot just keep on capturing, because you keep on capturing and all of a sudden the fish started, school of fish started producing like anything, and you have you get a huge amount of catch in a particular day. It is not possible. There is nature has its limited source, and the replenishment needs time. It's same as like renewable and non-renewable energy sources. isn't it? Fossil fuels has its limitation. We have specific amount of fossil fuels reserved in the earth. You cannot just keep on extracting and it will come out of nowhere. That is why the capture fisheries is almost at the same stage till 30 years back till now, and it's 96.4 the million ton. Whereas if you go to the aquaculture, total aquaculture at that point it was only 101, total 14.9 million ton. Now it becomes 82.1 million ton in 2018 data. This data is given from the source of Food and Agriculture Organization's data in 2020. If you think about in last 4 years, I can guarantee you, though there is no data available for that, but people are working on it, I can guarantee these values are almost same now. This capture fisheries and culture fisheries, it's contributing almost 50% of world fish demand right now, and in coming decade it will drastically change. It will just the other way around. Okay, the culture fishery will bloom like anything and the capture fisheries will not sustain at all, and that is because obviously it is not a sustainable way of doing fisheries in capture most of the cases. Okay, because it's our it's our hunger that we even if we want say like 1 kg of some stuff, but if we are getting like say 5 kg, we keep on extracting the 5 kg. We don't think about that extra 4 kg that if we left in the nature, that can give us another 16 kg in say like coming year. But we are greedy enough, so whenever we find an opportunity, we try to extract as many stuff as possible and get the maximum return, and we don't think about the future. So that will happen, and that's why capture fishery is not at all a sustainable way of capturing the fisheries and all. And so culture fisher will develop, aquaculture will develop. The total world fisheries and aquaculture contribution right now is around almost 180 million ton. Out of them, if you see almost if you think about the human consumption, almost 156 million ton out of 178 is for human consumption. Non-food usage is like almost 22.2. If you divide it with the population in billion, say like 7.6 billion, it was there in 2018. It will be if the per capita apparent consumption will come down to 20.5 kg per capita. This is per year. Okay, this is per year capacity I'm talking about. So in 1986 it was 13.4 kg per capita per year. Now it is 20.5 kg per capita per year. These human consumptions are increasing. This is like apparent consumption of per capita is increasing. Trade, if you see, like as of now, this fish export in value, it comes as high as 164 billion USD. Okay, it's a huge amount of money, and that's what I'm saying. I was discussing, like it's the time is changing. Like aquaculture will become something very special, and there will be it will not be under some specific if you see the changes in the United Nations, in the government, everywhere they started building a specific fisheries department, fisheries ministry, everything, because they know this is something its revolution is happening, and in the coming decade that will be the future. Okay. So if you see this in a world scenario, in this particular picture, the water 97% is salt water and 3% fresh water. However, almost 55% of marine capture is coming from the salt water, and whereas 32 is coming from the inland aquaculture, 9% from inland capture fisheries, and total 5% of marine aquaculture. So if you see this 9% capture and 55% marine capture, total almost 64% of capture fisheries, and rest is it should be 36, but it's like this point difference, and also 32 plus around 37, 36, 37. So almost 2/3 is coming from the capture fisheries, 1/3 is coming from the culture fisheries. This data is from like 2010 or something, but now things are changing. It is almost same 2018, as we discussed in the last graph. The same way, if we discuss about the same the different representation of the now world capture fisheries and aquaculture production is shown in this figure. Capture fisheries is shown in this this yellowish line and this orangish line. and the culture fisheries are given in this bluish lines, the deep blue and the light blue. Light blue shows the aquaculture in marine water, deep blue shows the aquaculture in the inland water. So, this curve is increasing as we discussed, right. This culture fisheries line is increasing. If you see the regional distribution, China once upon a time 1950, 1969, in that period, that 20 years of period, if you see the US, Asia, the America, USA and I mean like Asia and Europe has huge amount of aquaculture production and all compared to China, but now China is dominating like anything. It has surpassed all the other countries, and it is like almost beyond reachable right now in aquaculture industry. But still, that's why India is also focusing on it, and it has a lot of opportunity. People really can do that in India scenario. India has the capacity to reach that stage. Okay, that's why people are working on it, and government. We need a collaboration from philanthropists. We need collaboration from NGOs, policymakers, normal young population like you. So everyone should have to come forward and start working on it to make the things in a different way. This is also another interpretation of the graph that the table that we have seen. This yellow line is showing the population, and this red one is the per capita apparent consumption. See, the population is not increasing in a like almost in a how to say not in a the fluctuation. If you see the difference in the per capita apparent consumption is much higher than the changes in the population. Do you understand, right, what I mean to say? And the same way, if you see the food and the non-food sources, this non-food source use is almost the same, but food source, as a food source, human food consumption, that is also increasing like anything. This value is increasing like anything. So if you ask me that what is the role of aquaculture in like in terms of food security, in terms of food security of world, or in a overall world scenario. In general, the total fish production is expected to increase from 179 million ton in 2018 to 204 million ton by 2030. It's with the number you may think like it's just nothing, like around 24-25 million ton, that's nothing, but it is a lot if you see the number of zero that is there. So it is a lot. Okay, and the projected aquaculture, it's to be like from 109 million ton in 2030 to it can go up to 109 million ton by 2030, as it is said, like almost 32% higher than the value that is projected in 2018. Okay, it can be in forefront in meeting the future demand, as well as be demand for food, demand for non-food uses like pharmaceuticals and all the chemical uses and all. Because another reason of it, as I discussed, the growth of capture fisheries has stunted over time. It has the capacity, it has a limitation, it cannot go beyond that. Okay, improving the aquaculture sustainably is possible through what? Like definitely we have this improved farming techniques. We can improve the seed quality. We can improve the breeding technology, we can improve the feed that we are supplying, we can introduce some advanced technology to monitor, to observe, to get rid of all the disease, to identify, to classify them. These are important. Okay, and all these things, if we have it, all this data, we can definitely manage them in a better way. So that's what our goal should be, isn't it? So this graph is actually, this particular figure I want to give you to just to give you some idea about how efficient the fish is compared to any other meat sources. The protein retention, if you think, in case of fish it's like 31%, chicken 21, pig 18, beef 15. Energy retention 23% is fish, 10% in case of chicken, 14% in case of pig, and 27% is good amount in case of beef. But if you see the food conversion ratio now, it's 1.1, in case of chicken 2.2, in case of pig 3, in case of beef it's 4 to 10 kg. Now you must be confused, what is food conversion ratio, feed conversion ratio? feed conversion ratio means, suppose in the numerator you will be having the amount of feed that you have supplied. Okay. In the denominator you have the amount of feed that is actually converted into their biomass. Suppose you have supplied 10 kg of say like 11 kg of feed, and your supply is having, like at the end your fish production is like 10 kg. So what will be the feed conversion? 11 by 10, 1.1. That is the scenario in case of fish. Now suppose you have supplied 100 kg of feed, 100 kg of, like, you know, it's a lot of feed you have to give for one cow for their 1 kg of body mass conversion. So what will be the difference? 100 by say like 10 kg of body mass conversion. So 100 by 10. So that's like 10 of feed conversion ratio is 10. That means if you give 100 kg of feed to a cow, it will only convert to 10 kg of their body mass. The same way, edible meat. These are some some number that you should understand. In future, it will be very handy for you to, when we will be discussing. I don't have to give every time the description, all the detailed definition of each and everything. Okay. Fourth one is the edible meat per 100 kg of feed. Out of 100 kg of feed that you are providing, you can have only 61 kg of edible meat from fish. I am saying only because it's still good enough actually. If you talk about the beef, it's like 4 to 10 kg only. So the difference is huge, isn't it? So the discussions that we have in like last 20-25 minutes. So I would say, like, we need to introduce some high-end technology to this sector to make it to a better to give a better performance, or to give a more efficient way of culturing these different aquatic species and rear them in our hatchery, in our tank, in our pond. So everything, everywhere, like say if you are going to onshore practices, if you are going to high sea practices, these terms are maybe new to you. Onshore, high sea. High sea is like, high sea, just think about it. High sea is like, far away from the coastal area. Onshore is like, somehow it's coastal region and all. Think about it. Inland means in the land, inside the land. We'll have a, say like a pond. It's an inland culture. And so these are the different terms, terminologies that you will get accustomed with it the moment you will finish this lecture series. So technological intervention and innovations are very much important in aquaculture. Design of better facilities are required, so that the fish can grow in a more sustainable way. High-tech fish farming techniques has to be introduced, and the good thing is they are already there. The experts have already find out like tens of different practice techniques, or like ideas and all. Ideas are already floating in there. You just have to capture it, you have to grab it, and you have to introduce it to in your own field, or you can make it further better, just doing your own research. Climate smart aquaculture, precision aquaculture, and integrated aquaculture. Remember this three terms. You will get to see this, learn. I mean, like hear this word more frequently in coming decade. Climate smart aquaculture, where the aquaculture practices will be done without harming, without causing any environmental disruption, or I would say it will be carbon neutral or maybe carbon negative in such a way. Precision aquaculture, where you will use the system which give you like each and every. The precision agriculture involves your data. You will be using your machine learning or artificial intelligence and all. This ML AI techniques will be introduced to the aquaculture. It is introduced already in the aquaculture, and even we are working here in IIT Kharagpur as well, where we are trying to see use this machine learning techniques and all to develop the betterment, develop the fish in a better way, so to identify that if any small anomalies is there, we try to change them, we try to put it in the quarantine tank, and try to treat them as soon as possible. So there are different techniques which are already available, and the technologies are there, and if it can be useful, if you are using in a better way, in a perfect the way or road, it can give you a better food definitely in near future. Integrated aquaculture is not to be done in, it cannot go solo. You can do it as well as a paddy culture. It's called rice cum paddy culture. You can do it with the duck culture, with the duckery, with the piggery, with the livestock. It is doable. And what will happen, their excreta can be utilized for fish culture, like the aquaculture feed and all. And this way, it's like you can increase your economic return from your farm. Small scale fisheries and aquaculture are also gaining attention for their contribution to food, to produce food for billions of population and achieving zero hunger. So that is what our main target is, right? Like, as of now, I'll say the fish is considered sometimes very costly product, and it's only you can go and capture it. If you can do that, 1 or 2 pieces or something, like if you go to the most of the developing countries, they are not getting enough food. They are not having it's not accessible for them, this fish and all this meat products and all. For them it's something, they think about it, they dream about it, having 1 or 2 times this fish meal or chicken meal and all. Whereas some other part of the society like us, like we can even think about it. It's not something that we think even think about it, because we can achieve it. We can easily get the food. We can, and it's not something that we are bothered with. But for some people, there are I would say maximum portion of the population are still facing this kind of issues where they cannot approach to get a fish in a meal in a daily basis. So what we can do with this kind of aquaculture practices in a very sustainable and low cost manner, introducing technology, government's approach and all, it can make the difference. There will be a lot of people they can involve with it. There will be this protein, this very well needed protein source can be made available for each and every citizens of any country. So that is what the goal is, the aquaculture practice, the aquaculturist, and as an expert I would also say that is what we are actually working on. In conclusion, I would say this aquaculture is shouldering the major responsibility to meeting the growing demand of growing food demand of this population explosion that is happening all over the world, and thus ensuring a sustainable growth trajectory for aquaculture sector is very crucial. And it only possible that there's a huge scope of improving this aquaculture sector. It only possible when we do it through a conscious technological interventions, and that is what we'll be discussing in coming weeks. I hope you will get to know a lot of new technology, lot of new informations from this 12 weeks lecture series. And so good, so let's explore these vast possibilities in aquaculture sectors together in the coming weeks. So these are the references. You can take a picture or you can go through it. It will help you understanding this factor better. If you're interested, you can go through it, and it will give you much better a lot of new information about this aquaculture sector in general. I hope I can give you some basic idea about what I'm going to discuss in the next couple of weeks, next 12 weeks. And this is only the starting. I hope you get to know a lot of very important information in the coming weeks, which will definitely help you gather knowledge about this sector, and maybe you can make it helpful for you as well in future. Okay, thank you so much. See you in the next lecture video.